in Scotland. Good morning, everyone in Scotland, and good afternoon to those joining us from Malawi. You are equally welcome to this Scotland and Malawi Partnership Renewables Forum. From whether online and in this room, my name is Nasim Vadalia. I'm the Communications and Engagement Lead here at SMP. I'll shortly pass to our chair, Professor Stuart Galloway, who is from the University of Strathclyde. Just for a few housekeeping before we proceed with the meeting. There was not going to be any fire drills today. Just in case you hear the alarm go off, we'll have to evacuate the room and follow my colleague Dorothea here, who's going to show us where to go. For toilets, we have some just exiting behind the door there to the left. On the right hand side, you're going to see the business center. On the left hand side, that's where there's both gents and ladies as well. And there's also an accessible toilet right on that side. For everyone, this meeting is going to be recorded and it will go on our SMP events page. So if you're still remaining in this meeting, it means we've given us consent that we can post everything about you on the social pages and the website as well. For those joining us online, feel free to introduce yourselves in the chat log box. And also all the resources will be posted online as well that will be needed. And remain muted until you're asked to speak. That's when you can unmute yourself. Finally, if you are already an SMP member, we're happy you're here. And if you're not a member, we encourage you to join us. You can visit our page online or speak to any one of us in this room. I'll now please hand over to our chair, Professor Stuart Galloway, who can proceed with the meeting. Thank you.
Thank you very much. And so welcome to the presenters and colleagues, attendees and friends today to the Scotland and Malawi Partnerships Energy Forum. So welcome. I'm sorry that I can't be with you in person today in Edinburgh or in Malawi for that matter, but I'm really grateful, I'm sure like colleagues and friends in Malawi, that I'm able to dial in and participate in the meeting nonetheless. So my professional connections with Malawi are through the University of Strathclyde, and we have a long-standing connection with Malawi, and the team I lead in the electrical engineering department has worked with academic groups, NGOs, government parties, and there are a range of renewable energy projects that we've been involved with over the last 15 years. This continues today through our Global Renewables Centre, that we are the knowledge exchange work that we're undertaking through that, the ongoing collaboration with social enterprise mini-grid developers, with Community Energy Malawi and Kuyatsa. Damien and Aidan, who are working my team, are there in Edinburgh in person today. So please reach out and connect with them during the networking sessions. They'll be able to inform you about some of the work that we're doing, but also talk about things that we're hoping to do through the Global Renewables Centre in the future. So I'm really thrilled, though, to be spending time today discussing the topic and focus of this session, which is on hydropower. It's a vital resource, really, for large and small power systems in both Scotland and Malawi, and something that we all really need to try and understand a bit better, I feel, from an energy point of view. Looking at our agenda today, which I'm sure hopefully you've all had a chance to look at, there is 3 sets of speakers, and then we've got some sessions for discussion and comments. So hopefully it will be a vibrant and interesting set of talks. And then I'm looking forward to hearing some of the comments and engagement that we get in and around some of the ideas that we're hearing through that. First, we're going to hear from that in terms of speakers from Mambo, who is from the Mulanje Electricity Generation Agency. So MEGA, as they're known, are a leader in community-focused hydroelectric and mini-grid developments in Malawi. Their journey over the last 10 to 15 years has made use of hydropower resources from Mount Mulanje Massif, which holds some great, I think, and valuable lessons for us all. So we're really grateful, and thanks for joining us today, Samuel. That's really good. We're going to then hear from Callum Mcallister, who's a co-founder of Chipopoma Hydropower, a community-based project in the Rumpe district in Mashetwe in Livingstone. Chipopoma Power generates hydroelectric using Malawi's highest waterfall. So we may get to see some nice pictures of that as part of the talk, you never know. But then that power really that's generated from the hydro schemes is distributed to households, you know, a number of businesses and schools. So they can again give us some, like a fascinating link with MF Coffee, the project they're doing with Cameron, who I'm hoping is already also engaged in this meeting today. And finally, I'm delighted that we've been able to secure the time of a former PhD student of mine, Kyle Smith, who's there in person. He's going to be telling us a little bit about the work he's been doing through his company, Energy Mutual, and what he's trying to achieve in and around hydro for communities in Scotland. And I'm hoping that we'll all see some parallels with some things that are happening in Malawi. So without further ado, I'd just like to say thanks again to everybody, presenters, colleagues, attendees and friends for coming along today. And hopefully Samuel is ready to start, and we're going to hand over him to hear a bit about the mega journey. So thank you very much.
Hello, everyone.
Hi, Samuel. We can hear you.
Can you hear me? Yeah, I hope I can be heard. Thank you so much, everyone. Good afternoon. As earlier stated, I am Samuel Mambo. I am working with the Mulanje Electricity Generation Agency, in short, Mega Limited. I've been around. I started working with Mega Limited from 2016 February up to today. So I'm happy to be part of this renewables forum and present on what we are doing at Mega, and so that people can hear the Mega story. So thank you, everyone. Can I have the slides, please? Yeah, so I'll start with the first slide. From the first slide, I'm going to show you how the mega generation infrastructure is spread along the Richenya River, where we are generating from. So here we have Bondo 1 intake, and just below this, about 600 meters from that, we have Bondo 1 powerhouse. So Bondo 1 powerhouse is the first one that we started constructing, including the Bondo 1 intake. Construction started in 2009, and then it got online. It got commissioned in 2013. Along the line, from 2016, we started working on Bondo 2, but previously we had started working on Bondo 2 just here. And then we had a cyclone in 2015 that washed away everything. And 2016, we started rebuilding Bondo 2. I'm happy to report now that Bondo 2 is functional and it's operational, functioning very well. And it got commissioned in 2018. Here is the intake for Bondo 2. And just down here, we have Bondo 3, which gets its water from Bondo 1. Previously, we used to discharge the water from Bondo 1 into this river, the Richenya. But then we built a phobe here. Instead of taking the water back into the river, we put a penstock here, which is 1.3 kilometers to Bondo 3. So Bondo 3 is our biggest power station, which is 160 kilowatts. Bondo 1 has got a capacity of 80, and Bondo 2 has got also a capacity of 80. So from this, you can see our systems are cascading. Next slide, please. Yeah, so about Mega, it's a social enterprise. We are operating in Malawi in the region called Bondo in Mulanje district. It was established with the purpose of generating or developing, operating, and maintaining microhydro schemes that would be developed around Mulanje Mountain and beyond. I'm saying and beyond because the main reason for Mega was to take care of the conservation of Mulanje Mountain. But now for the very sustainability of Mega, we are thinking that there are other opportunities elsewhere in Malawi, and we are also exploring chances of starting developing those sites. So our aim is to supply reliable electricity through an environmentally sustainable model. Mega is the first licensed off-grid mini-grid in Malawi with both generation and distribution licenses, and all our projects are designed to be implemented using community participatory approaches. This is because we just wanted to enhance ownership, which has proved to be working perfectly at the moment. Next slide, please. So, like I have said, we have got 3 powerhouses which are cascading that were constructed between 2009 and 2018. And we have got a total capacity of 220 kilowatts. This is usable, but installed is 330. But what we can use at the moment is 220 due to other issues like inefficiencies and the like. So from this, what we have done is we've managed to connect 2,150 customers, out of which 1,750 are households. We have got 350 businesses, and we have got over 50, social connections. In the group of social connections, we have things like churches, health centers, child-headed families, female-headed families. We have also put them on a social tariff. So from my explanation, we, in terms of our generation, we have 3 step-up transformers, and in terms of distribution, we have got 12 step-down substations located across the area where we are doing our works. So the local economy there is mostly driven by tea and pineapple farming. Of course, there are also a lot of avocados that bring, a lot of money to the people there, and lots of fruits like bananas, lychees, and the like. So in the Richenya River, there's significant additional hydropower potential. Our studies show that we can upscale our generation up to 6.5 megawatts on the existing site. And in the area, there are low levels of electrification in surrounding areas. I would say there are about 8,000 unconnected potential customers. And it has, we have seen that there is significant ability and willingness to pay amongst those that are even not connected. May I have next slides, please? So from the first slide, I think you have seen Mulanje Mountain Conservation Trust. Mulanje Mountain Conservation Trust are the original owners of Mega. They are the ones that formed Mega. Before we had Mega, they formed what we used to call Mulanje Renewable Energy Agency. So Mulanje Renewable Energy Agency is the vehicle that started construction of Bondo 1 from 2009 up to around 2013, when Bondo 1 started to get operational. But then there was a problem to see, in terms of sustainability, there were issues like, how is it going to be run? So that's the reason why MMCT came up with an idea of forming Mega to act as a vehicle for the operations of, the generation and distribution and everything. So MMCT was motivated by sustainable economic development and conservation of local natural resources. And they've got so many years of history working closely with the Malawi government and the donor community. Next slide. So from what I have said, I just want to take you to Bondo So just feel like you are in Malawi, you are in Bondo, and then I'll be showing you what we have done. Here, the first photo here that you are seeing on the left of your screen is the intake for Bondo 1 that I mentioned. And this is the forebay, or a settling tank, if you like, for Bondo 1. And just here is where the canal starts. From this canal, it runs for about 680 meters. And then there's another forebay. And then there's a penstock. And then the water gets to this powerhouse on the photo to your right. So this is Bondo 1 powerhouse. It has, I mean, the turbine. Here's the turbine, and then we have got the motor here, and it has got 3 valves. Can I have the next slide? This is the canal that I was talking about, Bondo 1 canal. And on the middle here, this is the penstock, which is 120 meters. And then on the right here, we have got our first substation, stepping up substation. Next slide, please. On the left here, this is now the Bondo 1 powerhouse. You can see it. And then the photo on your right is the spillway. You remember I told you about, at first we were discharging the water back into the river here, but then we now built this forebay to act as an intake for Bondo 3 powerhouse. Next slide. Having talked about Bondo 1, let's get now to Bondo 2, which is at a distance of 3.5 kilometers up the mountain from Bondo 1. And here on the left, it's the inside of Bondo 1. This is the turbine for Bondo 1, and this is the generator. The generation capacity is 80 kilowatts, like I said, and the turbine is cross flow, as most of you who are, as you can see there. And then on the right here, we have the powerhouse. Next slide. Yeah, so here, I just wanted to show you the infrastructure for Bondo 2. This is the intake for Bondo 2, and this is the canal. Just behind this rock is where we're having this forebay. And then this is the penstock for Bondo 2, which is 80 meters long. Next slide. That's about Bondo 2. I will now take you to Bondo 3 powerhouse. This is the Bondo 3 powerhouse that I mentioned about, which is at a distance of 1,300 meters or 1.3 kilometers from Bondo 1. Next slides. This Bondo 3 was constructed from 2017 to 2019. And in this, I'm showing you the inside of Bondo 3 powerhouse. This what we are seeing is this is now the turbine, Peyton turbine. And this is the generator or alternator, if you like. This is the flying wheel. And just behind here are the controlling boards. This is the ELC, this is the dump load board, this is the distribution and everything. From the right, I think I just wanted to show you where the water is coming from. This is the pressure gauge. And this is where we control the water flow sometimes. Next slides, please. Just behind the Bondo 3 powerhouse, we have got this house, which is housing this transformer, a stepping up transformer. And here we have got an office where electricity sales take place. Next slide, please. Yeah, so I just wanted to show you how we are operating at Mega. We have got a village electricity committee, which has been represented in this photo from by this senior group village headman. This is the secretary for the electricity committee, and this is the committee member who is the chief for the village where all the 3 power stations are located. It's called Kalama. This is myself. This is my fellow workmate, generation supervisor. This is our accounts guy. And this one was a visitor during this time of, photo taking. So this Bondo 3 power plant generation was funded by the Scottish government, which was engineered by SGAR Energy. You can see here, we said we wrote everything. And it was also co-funded by the Global Environmental Fund and the Department of Energy through the government of Malawi. So you can see that I'm happy today presenting to you what has been happening. I mean, with all the funding that came to Mega, and I'm here to tell you how it's benefiting the local communities out there. Next slides, please. Yeah, so I'll talk about other operation parameters. Our transmission is through 11 kV, and we are stepping down to 400 volts. On site, we have 11 linesmen that take care of, construction, because we have got an inside capacity for construction, house connections and the like. So these guys, 8 linesmen, are responsible for house connections, grid maintenance, whatever you may call it. And from the 3 powerhouses, we have got 13 powerhouse operators who work in shifts. And we have got 8 security personnel just to look after, our infrastructure. And then we have got 3 clerks who are responsible for electricity sales. All our customers are on prepaid. And then these clerks are responsible for selling units to them because we are not yet online. We are doing it manually. So it's like a customer comes to me today to say, I want units worth 5,000 Malawi kwacha, and then a receipt is issued to them, and a sales sheet is brought to the office Mondays and Thursdays, and Mondays and Fridays. And Tuesdays and Fridays is where electricity tokens are generated and sent to the site and get distributed to them. In terms of tariffs, we have got 3 tariffs. There is a business tariff, which is at 14 cents. There's a household tariff, which is at 9 cents. And then we've got a social tariff, which is at 4 cents. Next slide. 4 cents per kilowatt hour. Yeah, I'm not able to see clearly because it's like scrambled from my side here, but I know what I need to talk about. So I'll talk about the mega successes. We are saving at the moment about 10,000 direct beneficiaries. I'm talking of 2,150 households connected times maybe 4 or 5, because that's, an average, capacity for each household here at Bondo. So 10,000 plus direct beneficiaries of electricity and over 30,000 indirect, maybe over, because these people benefit through maize mills, which are 13 in the area. There are 9 primary schools. These are government primary schools, 4 secondary schools, government secondary schools that we've connected. There's a health center, a government health center. There are businesses like, welding, salons, and so many things. I'm not able to read, but there's just so many. So from these, even those people that are not connected, they are benefiting, not directly, but indirectly, because when they go to Bondo Health Center, they are helped, they get the assistance, because, the facility, the health facility is connected to electricity, and the fridges and everything are working. So medicine, vaccines are well kept. And again, staff has been maintained, which was a problem before electricity. I'll show you a slide where we've connected, staff houses for, those working at the hospital. Now they are attracted to Bondo because there is electricity. But before, people are not attracted to work at Bondo Health Center, just the same as primary schools. Now people are attracted to go and work in Bondo because they know that, the teacher houses are connected, they'll have electricity, so they are happy there. Next slide, please. Yeah, this is just an example of our successes. You see, this is just a newly built secondary school which we have connected. And on the right there, you can see a well-illuminated classroom. Next slide. Here, you see people doing photocopying, printing, and a burning center. So it's helping the local economy there as well. Next slide. Here, just wanted to show you what Mulanje Mountain Conservation Trust is doing. They are constructing this, what they call Inde agro-processing industry. It's under construction, but this will be one of our major off-takers as well. In the way we want to improve our productive use of electricity. Next slide. This to the right, to the left, this is one of the maize mills. Out of the 13 maize mills I mentioned in Bondo, just behind this you can see our grid, because this has to be connected to 3-phase. So it's, you can see here. And then on your right, you can see we are also promoting clean cooking. Talking about clean cooking, so we made it possible for people to buy, these electric stoves at a subsidized price. As I'm talking now, there are about 500 people that bought, these stoves, but others were on study. So that's why just above the hot plate, you can see this meter. So we are recording how they use energy usage and everything, and then we can monitor how much they are using for cooking. And in addition to this, Zuzu, we are working with Zuzu University at the moment. So they've bought also 250 pressure cookers. The reason is we want to find out whether pressure cookers will reduce, the amount of the amount of money they buy for electricity for cooking, because pressure cookers, they can cook fast, they can do everything. So there is that study that is happening. So there is a lot that's happening in the area as well. Next slide, please. Yeah, so there is also an opportunity for research. The photo on the left is showing you, we keep receiving students coming. You talk of undergraduate, you talk of, master's students, PhD students. So this is just an example of how Bondo has transformed to be, an area where people can do studies. And on the right here, I just wanted to show you how we are improving the local economy through employment. So out of all those, site workers that I mentioned, we've employed them from the site, from Bondo. So all the people that do everything, they are from Bondo. This is an example of how we are doing the work. This is where we were installing a transformer somewhere. Next slide. Yeah, this is just an example of Bondo Health Center. You can see it's connected. And on the right, there are several houses for the staff working at the Bondo Health Center. Next slide. Yeah, in this photo, I just wanted to show you so many businesses that are taking place in Bondo. So there are lots of, groceries. Like, for example, you can see this one. It's in the group village Hedimani Bondo. And then just below this, we have got a hair salon. On the right, you can see a well-connected house with a TV on top. And then just below that, you can see even there's this This is what we call egg, say hatchery. Yeah. So people are doing, different types of businesses using electricity, as you can see from the photo. Next slide, please. Yeah, so having talked about what we have done, let me just take you through our struggles or challenges. So the main challenge that we are facing at the moment is financial constraints, which is hindering grid densification and expansion. Talking about grid densification, in the area, the existing area, we have got like 300 customers that already had paid to Mega their electricity connection, but we have not yet connected up to date because we are struggling to buy, materials like drop-down cables and D-irons. Previously, we had the problem of meters, but we sourced them. We have got plenty of meters now, but then we cannot afford to buy, things like drop-down cables just to connect these 300 peoples.
Hello, Samuel, are you there? Now, we seem to have lost Samuel's connection temporarily. Yeah, hopefully he can come back. Just give him a moment to see if he can reconnect. I'm not sure who's controlling the slides. Dorothea, perhaps? Maybe we could... oh, hold on, he's back.
Yeah.
Ah, sorry, you're back, I think.
Yeah, so I'll just go through quickly. I'm about
Yes,
to finish.
please. We've got only a few. You've got maybe 2 or 3 minutes left.
Yeah, sure. So let me just go quickly. Yeah, so there are those people. So we have got an opportunity to connect about 600 people using the existing generation capacity that we have. But the problem is still financial constraints. And I think, again, like I have said, we can also upgrade our generation capacity to 6.5 and then connect, the remaining 7,000 and even sell the rest to the national grid. The other problem is deforestation, which is leading to river siltation and flooding. And then we have got also another challenge with poor policies and regulations in promoting mini-grids. And then the other problem is technological barriers. You see, at Bondo, because of our financial constraints, people are still buying electricity, using odd ways. They are not online. There are issues of power limiting, which could have been done remotely now, using technology, fault detections, and the others. Next slide. Yeah, this photo is just talking about because we have failed to connect these people. There are regular, frequent meetings with unconnected communities. Most of the times calling us to address the accessibility issues. So these photos are just showing you an example of how things happen. Organized by chiefs, you can see chiefs there and the community. Next slide. Here, I was trying to talk about the deforestation, evidences of deforestation. You can see how heavily Mulanje Mountain is being deforested here. And you can see, the logs of wood here It's like normal business at the moment. And you can see here, this is at Bondo 2 I mentioned about. Going here is where the intake is. And down here, if you can see properly, you can see the penstock here. The Bondo 2 powerhouse is here. But you can see how, degraded the area is becoming. You can actually see the vehicle here through the access road that we built. Next slide. Yeah. This is a good example of deforestation because, the trees have been cut. There are, landslides which force big rocks like this to slide down, destroying our infrastructure. You can see how it's happening here. And on the right, you can see the evidence of siltation. Just having a little amount of rain, we have, plenty of this trash. And then it needs us, to start, cleaning. Next slide, quickly. Yeah, so we are doing something to mitigate all this deforestation. So this is what we are doing. You can see this truck is fully loaded with seedlings, and I'm working with the communities to help, in reforestation. So what we have done at the moment, in each village, we've set up a club to manage watershed. So this is what is happening. At the moment, as we are talking, it's a rainy season in Malawi, and we are busy planting, not only planting, but we are also encouraging them to take good care of those planted trees and also try to avoid, bushfires. Next slide, please. Yeah, so this will be my last slide. Here, I just wanted to show you our existing grid and our expansion plan. Sorry that it's not yet updated, but you see from these rates, these are the generation points. This is Bondo 1, this is Bondo 2 up here, and this is Bondo 3. All these blue circles are the substations that I mentioned about that we've managed to construct. This one is done, Kuta is done, Kashon is done as well. What are remaining is the rest of these except for Bondo 2 and these 3 here and all these here. So when I'm talking about 7,000 customers, I'm talking about customers from these areas and including those that are remaining within the existing grid. I think this marks the end of my presentation. Can I see the next slide if there's any? Yeah, I don't think there is any. Thank you so much.
Thank you, Samuel. Thank you. That was great. Some really great pictures there. We have time for one question. If anybody would like to ask a question. So you'll have to field the questions if it's one in the room in Edinburgh or again elsewhere.
That was a quick question for yours, here. I noticed in your pictures in the powerhouses that you had blue and green barrels there. Are those your dump loads for frequency control?
Are you talking about the dump loads?
Yes, yeah. Is that what they were?
Yes. So yes, we had those dump loads because we had excess energy, but now we have found a use for the excess energy. What we did, we are using our stranded energy to run the data machines processing Bitcoin at the moment and get at least a little something out of the stranded energy.
Thank you.
Good. Excellent. Thank you. Thank you very much. Yeah. So I think in the interest of time, we'll maybe move on to our next speaker, if that's okay, which should be Cameron. Hopefully Cameron's ready to go, and there'll be time to speak, to ask questions, across all our speakers at the end of the presentations as well. So if we can just maybe move over to Cam, that would be great.
All right. Should I just show the slides on my computer?
That'd be great, and you can, so if you want to share.
I just have to allow to use my screen. Okay, maybe do you have
I've got them to like them.
Yeah, there we go.
Yeah, you can hopefully just use this.
oh, perfect. I'll just try this out. Yep. Okay. So my name is Cameron Mcallister, and I lived in Malawi from 2013 to 2020, where I owned and operated an eco lodge called the Mushroom Farm in Manchewe village. During my time there, I saw firsthand how the lack of electricity shaped daily life, limiting opportunities, making basic tasks difficult, and holding back businesses that could have thrived with reliable power. Today, I'm just going to share kind of the backstory of Chipopoma because I think it's a really fascinating story and it all centers around this one guy who's on the screen now. It wasn't started by professionals or a large company. It was started by John and his vision to electrify Manchewe. He is on the screen. His name is John Silence. He is the director of Chipopoma and he is the lead engineer. He grew up in Manchewe, a village that never had electricity, but he imagined a future where that could change. And in 2015, we started working together to turn that idea into a reality. Today, John leads a fully functional hydroelectric project providing renewable energy to over 125 homes, businesses, and essential services in Manchewe. John always had a passion for electricity. This is him here as just a young boy in Manchewe. This is where he built himself a small fan using scrap metals. With no formal training, he taught himself how circuits worked, taking apart old radios and small motors. Here we are with John, and on the right is our good friend and mentor, Hastings and Kandawiri. He's an exceptionally talented guy who's from Mzuzu. He's built over 60 kind of micro hydroelectric generators in northern Malawi. And we found out about him through word of mouth initially. He's also self-taught, never had any formal education, but is just an incredible engineer, kind of a 1 in a million guy. Behind them there, you can see Manchewe Falls. Those are the waterfalls that we harnessed to provide Chipopoma with electricity. Here's another shot of it from below. It is the highest waterfall in Malawi. It drops 125 meters from the top to the bottom. It's not all a sheer drop. There's some steps in between, so it's not straight up and down, but there was plenty of abseiling. This is a homemade alternator, and across Malawi you'll find homemade alternators like this. This one in particular provides electricity to 2 houses. And growing up, John saw these small alternators, and he got inspiration to build a much larger one in Manchewe. Here's the owner and builder of that small alternator that provides his home with electricity. It turns out that John just so happens to be a really incredible chef also, and he just coincidentally started working at the mushroom farm, which is where I was working at the time, and that's how we met. And it's there that we started talking about the possibilities of hydroelectricity in Manchewe, and it was there that he kind of shared his ideas with me. At the mushroom farm, we were relying on solar electricity. We were completely off grid, as everywhere is in Manchewe. So the idea of kind of renewable electricity was something that was really fascinating to us. So we kind of gathered momentum, and before we kind of started on this project, we consulted the local chiefs and local business owners and the community to explain kind of what we wanted to do. I don't think at that time anyone kind of believed it would come into fruition. Once we had their support, though, we bought our first pipes. These were the only pipes we could get in Malawi, which were kind of old secondhand PVC pipes. And we had to kind of hook those up to the 125 meters of rock face. John also, as well as being an incredible engineer and chef, he also knows how to abseil. So he trained a team of local guys how to abseil down the rock face. We got in some equipment from South Africa to do that, and about 8 people that he trained to abseil. One of our biggest and here's the original pipe, the original PVC pipe. There's my dog Billy. This is it. Looking back at it in hindsight, it was just incredible that even worked for a small amount of time. One of our big breakthroughs came when William Nicholson, an engineer from Brighton, he was a guest at the mushroom farm, and he heard about our project and he really wanted to help. And he decided to stay in Manchewe for 2 months and helped John and worked with him closely to develop and refine his design. He's quite the whiz at mathematics, and he kind of came up with this design that we could take to Hastings and Kandawiri for him to manufacture. Here's the alternator that we got is actually from South Africa, and as my dad actually drove it up in the back of the truck. And that's Hastings' workshop in Mzuzu, where we dropped off the alternator in the beginning, so he could kind of assemble the turbine that he built out of scrap metal. This was his handiwork. And that alternator, by the way, is a 53 kVA, and it produces 42.4 kilowatt of real power. To protect the whole system, here's the kind of design as it was in Hastings' workshop before the team had to kind of take it down to the bottom of the waterfalls. This was in the early stages. All of that was made using scrap metal that Hastings was able to find around Mzuzu. The guys had to take the entire, what you saw on the last slide, all the way down to the bottom of Manchewe Falls, which is about a 1 kilometer distance by foot. It's really steep. It was really harrowing to watch this unfold. The alternator, for context, weighs 250 kg, so it was quite the effort to get it to the powerhouse. But they managed, and they got it down there, and a team assembled it at the bottom there, and because it's Manchewe, there's a lot of very, very talented builders, and so they are able to put that into place. From there, we were working with a really limited budget. At this time, we were completely funding this through profits from the mushroom farm and small donations from here and there. So our budget wasn't massive, but we managed to get it to a point, but we could not afford a distribution network in any way possible. So we started off, we did have a budget for a centralized maize mill, where Hastings also built the maize mill. We got on 2 motors to run it. But this was the first thing that we wanted to hook up using the power generated from the waterfalls, just because it was the most pressing concern for the people of the area. And also, we obviously had outlets there that people could come and charge their appliances at a centralized location. So after approximately 6-7 months of work, we hooked up the maize mill and started generating electricity, and enough electricity to power the mill and to power some charging stations. But after that initial it's about 4 months, the maize mill was working. It was kind of on and off, just because simply the PVC pipe couldn't withstand the enormous pressure of the 125 meters of drop. It just simply wasn't made for that. But during that 4 months of us running the maize mill, the United Nations Development Program kind of caught wind of what we were up to, and it just so happened that they were initiating a program that was directly supporting mini-grids throughout all of Malawi. And that's actually where we kind of got the contact details for that. And some of the team members there who also kind of helped us out with some of the technical aspects of our project. But also with their support, we were able to buy these big HDPE pipes, sorry, from South Africa, and we got a truck to deliver them directly to us on the mountain. Each one of these is 6 meter length, and each one weighs 250 kg. So putting them into place was no easy feat, but the team there somehow managed to do it using a winch and abseiling, and they managed to kind of connect it from top to bottom. I'm not sure if I can play a video on here. Maybe this button. Oops. Shoot, sorry, I think I pressed something that I shouldn't have. Oh, okay. Well, that's kind of a small example of what it looks like from at least one of the shear drops, and that's it going into the powerhouse. There we go. So, and then it started, where we at here? It started working very well with the UNDP's help and with the new pipes in place. The whole system kind of became a lot more powerful than it once was and became a reliable source of electricity. Let's kind of skip in ahead here. I think it's on autoplay. There we go. So I think this is back where we were. Let's see. So maybe while the picture is loading, I can just explain that Hastings also, after the initial turbine, we got a small budget to build a new one. We looked into importing a turbine, but as it would have been at least £20,000 to kind of import such a turbine. So we had Hastings build yet another one for us, which is working to this day. This is it in action. And also then with the UNDP's help, we managed to build a distribution network, distribution grid, which carried the electricity to the 3 surrounding villages throughout our area. So we are no longer confined to just providing power to the maize mill. We could provide power directly to people's homes. And the UNDP contracted out an engineer to take on this job. But one of the stipulations that we had in place was that he had to work with a team of local guys and ladies to teach them how it works, to teach them how to fix anything if anything should go wrong, so we didn't have to rely on outside help. Here it is throughout the whole village. So yeah, they never had to kind of come back and fix anything if anything has gone wrong, but our team in Chaney has been able to kind of make it right again. This is our board minus one lady. You can see John there, I'm in the back, that's Fishani and Frida, and that there is Josh, who is also our accountant and manager. Our board is comprised of 4 women, all from the area, and they host regular gatherings to discuss the best way to distribute electricity. Chipopoma also sustainably employs 10 full-time workers, thanks to the tariff rates that we charge to the villagers who access our electricity. Thanks to we've also reached out for a few grants that have kind of helped us along the way. We've got a grant from the U.S. Ambassadors Fund and from the Titus Foundation, which helped us to replace a step-up transformer that was hit by lightning and to help us pay Hastings to build another turbine for ourselves. In the future, we hope to combine our hydroelectricity project with perhaps a kind of a solar field, because obviously as a hydro project, we do suffer in the dry season. We do have to load shed throughout the day. We have about 4 hours where there's no electricity. It's becoming more manageable, and the team is also working at the moment on building a dam, just to, it won't obviously give us more water, but we can better regulate how we kind of organize our electricity distribution throughout the day. But we would love to look into complementing our hydroelectricity project with a solar system. which John has also been to visit the solar field in Benza from the University of, that was one of the projects at the University of Strathclyde, and has gained a lot of inspiration from that project. I am currently sourcing a new alternator. I've been talking to Mcallister, and we're looking into buying that hopefully within the next month, and then shipping it over with Alan Lovemore, who's a Scotland and Malawi partnership member who he has a program called Banana Box, which ships containers to Malawi. So hopefully we can put it on board with the next container going out to Malawi, and kind of save us a lot of hassle. Instead of buying one from South Africa and shipping it up, it might be easier doing it this way. Additionally, I'm currently in the process of setting up a charity in Scotland, or OSCR as they're known here. This is just to fundraise and to kind of raise awareness of what we do. We're going to start by building a website first and foremost. The hydroelectricity project obviously has many benefits. For me personally, I work with coffee farmers in the area, in the Mcallister area. And it's allowed us to just handle all of our coffee processing kind of in the village that the coffee is grown. Instead of having to outsource and to send coffee to the next closest dry mill, we're able to take on all the processing ourselves, which allows a lot more value to kind of stay in the village. Our next goal is to build a coffee roaster, also reliant on Chipopoma power as electricity. Some of the challenges that we face are we do at times overload the alternator. We hope to introduce a time-based pricing. I know that Mega has that. But currently it's been really difficult because we actually don't have prepaid meters. We were just doing a basic tariff rate, a basic flat fee for any user of electricity. So there's a business rate and there's a personal rate for any user of the electricity. This is not by design. We've been discussing with the United Nations Development Program for over a year now for them to kind of give us prepaid meter boxes, which they have assured us. It's been a long logistical kind of nightmare. Until that time, we won't actually know how profitable the project is. And also we will be experiencing difficulties with overloading the alternator at peak hours, because if electricity is completely free, people are kind of a bit more kind of unaware of how much they're using. So that is definitely going to change a lot about how we manage the project and the amount of money that we bring in from the project once we get these meter boxes in place. Another challenge that we face that we already kind of touched upon is lower water levels in the dry months, requiring us to load shed. Lightning damage has hurt the project. It hit one of our step-down transformers, as well as hitting the alternator, which we had to get rewound in the Zuzu not too long ago. But now we use lightning arresters, and we kind of put the precautions into place to hopefully mitigate that in the future. We are going to get a larger alternator. Our infrastructure can handle it, and so that's what I'm looking at to send over there with the banana box. As I say, our electricity tariffs are among the lowest in Malawi. We probably charge the cheapest price out of anywhere in Malawi, but this is a mistake. This shouldn't be the case. We want to be cost competitive with Eskom going forward, just so that we can be a sustainable business. Because right now, with that, our basic tariff rates covers our 10 employees that we have running the project on, and kind of our basic maintenance. But if any large scale accidents should happen, or lightning should strike again, or any big parts to the project need to be fixed, we kind of have to seek outside grants in order to fix those issues. So in conclusion, since introducing electricity, Mcallister now has a police station powered by Chipopoma power. Our maize mill is still running strong. That is under the ownership of John now. We have a primary school that's powered by the electricity. There are 2 churches. There are multiple welding businesses, barbershops, hair salons, small grocers with refrigerators. There are probably too many pubs that have popped up, and they're all showing the football matches. There is now also reliable power for medical storage. People can now store important medications in Mcallister using freezers. which is a great thing. And also, as Mega has touched upon, the forest has kind of definitely, we've seen noticeable improvements to the forest. It's now growing back as reliance on firewood has drastically decreased. It's some of the most reliable electricity, aside from a few days during the driest of seasons. We have some of the most reliable electricity. And so even people from Livingstonia is supplied electricity by Eskom, but even when they are load shedding, a lot of customers will come down to the Manchester to use our electricity. So in short, Chipopoma has kind of changed Manchester. It all started with one self-taught electrician and his team who were kind of willing to take risks. And it's a story about John and his kind of perseverance to make this happen. And he is still the director and the lead engineer of Chipopoma Power. We're still working very closely with Hastings and Kandawiri. And yeah, we're just trying to grow the project as big as it can get. So thank you very much.
Cameron, thank you very much. That was really an impressive presentation, and one I think which we can see some real progress there in the work that you've been participating in. I think there's one question from Samuel really, which is in the chat, which is really, what is preventing you to start using these electricity meters on the billing system? Because obviously this will improve your revenue base. Have you got a quick answer for that?
So it's all too complicated for me to understand. So basically, we were given prepaid meters from the United Nations Development Program probably about 3 years ago. They put them into place, and I think they were connected to another mini grid in Malawi in an effort to save money. The United Nations decided to not kind of hook us up with our own computer to control our system, but to then instead like hook us up with a second village that was already distributing these tokens. But then that village that we were kind of partnered with didn't have reliable internet, and we couldn't communicate directly with them. So that first load of prepaid meter boxes was taken away. And now over the past year, it's just been a constant back and forth about these new prepaid boxes coming in, and we have to change the code on them in order for them to be like set up and to be able to work with Chipopoma Power exclusively, because apparently the code was registered to a different business, and just that process has been just like pulling teeth essentially. So we're working on it. We've got a good team kind of working and are helping us out with it. So we've been told that hopefully within the next couple of months we'll get these new prepaid meter boxes to kind of help us.
Okay, great. That sounds good. I mean, Samuel also mentions he's seen some good things in Chipopoma in terms of metering and through the Ministry of Energy in Malawi. So it might be worth following up on that if that's something you're not familiar with. But thank you again for the presentation. It was really good. And so in the interest of time, because I'm not doing a great job of keeping us to time here because the presentations are so interesting, I'm going to now hand over to Kyle Smith and hopefully he'll tell us a little bit about his work up in the Scottish Highlands.
Okay. Presentations would be... Well, good morning, everyone, and good afternoon to everyone in Malawi. And as Stuart said, my name is Kyle Smith, and I work for a company called Energy Mutual. And over the past 10 years, we've been supporting a community energy company up in the northwest of Scotland called knoydart Renewables. And for the next 10 minutes or so, I'll give you an overview of where knoydart is and the kind of history of this energy system. But in this opening slide, you can make out a reservoir on the hill here. This is called Loch Broomstage. And you can make out an access track that winds its way down the hill. And at the bottom of the hill there's a powerhouse. And this loch feeds a 300 kilowatt hydropower scheme. And so far, in the past 25 years of community ownership, that loch hasn't run dry. So it's a very good energy source for the community, very reliable. It kind of acts as a giant battery. So I'll give you a quick overview of knoydart and the energy system, and I've actually increased it to 25 years, so we're entering 2025, and the community took ownership in 2001, was when there was the first main refurbishment of the hydro scheme, and then we'll do a bit of looking forward and how this community might grow and how the energy system is likely to grow. So where is knoydart? Well, it's in the northwest of Scotland. It's only accessible by boat, so it's a remote peninsula. So you either take a half-hour boat ride or you walk 3 days to get into this little community. And in 2000, the community got together and purchased 17,500 acres of land that had previously gone through several different private ownership exchanges. And 200 years ago, there's about 2,000 people that lived on this land. And there was a dark period of kind of Scottish Highland history where they got cleared off the land. And now there's about 100 people that live there permanently. But it's a tourist-based economy, so thousands of tourists come here every year to enjoy the mountains and enjoy the landscape and the coastal areas. So this community is powered by a 300 kilowatt hydro scheme. It sustains the community throughout the year, and then also there's additional power capacity in the summer months when the tourist influx. And when the community bought this land, they acquired the dilapidated hydro scheme and the electrical infrastructure, and they set up a community company called Knoydart Renewables, and they operate the hydro scheme, the distribution grids, and the billing and metering. And it's this community company that we've been working with. So those of you interested in the kind of engineering side of things, this is what the network looks like. It's a single line diagram. So on the right hand side, you've got the hydropower house that feeds a step-up transformer, just like Samuel was discussing earlier, and that feeds an 11 kV distribution grid, which historically has been an overground or an overhead line, but that was just recently undergrounded last year. So we have lots of reliability issues. There's an old overhead line, failing poles, lots of branches coming down the lines, more storms coming through that are causing issues. So now it's all undergrounded. It's a 7-kilometer distribution system with several step-down transformers feeding different loads. And then in the middle of the community, in the middle of this network is the main village. And there's 2 100 kVA backup diesel generators that supply the network when the hydro is down for maintenance or there's a fault in the network. And within the village, there's more density of housing, so we've got more low voltage circuits that can be isolated and switched in and out. So that's an overview of the network. But it didn't always look like that. This is what it looked like when the community took ownership in 2001. So at the time in 2001, there was no power. The power was just supplied temporarily by diesel generators. And this is what the dam looked like up on the hillside of Loch Brosig. And this dam was actually installed in 1976 during the oil crisis. So the oil prices went up. It was unaffordable to run the diesel generators. And the previous private landowner decided to build this hydro scheme. But it was just built out of locally won rock and material, and then a small concrete cap over the top. But by 2001, it wasn't really doing its job, and it was releasing a lot of water. So the refurbishment project took place in 2001, and that got the dam rebuilt and a new pipeline put in. But there's no access to this dam, so to access it, you had to walk an hour and a half to get up to it, and any materials had to be flown in by helicopter, so very expensive to maintain. And unfortunately, during the refurbishment in 2001, the main contractor went bankrupt and took a few cost-cutting measures along the way, mixing sand from the beach with concrete, and so the concrete was poor, and the pipeline wasn't laid as well as it should have been. So by 2010, there were some issues with the pipeline. The pipeline wasn't delivering the power we needed at the powerhouse. So although it was rated at 300 kilowatts at the turbine level, the water delivery could only give it 180 kilowatts. And by 2010, the community was growing and was outstripping what the power could be, what the turbine could provide. And so there's demand management requirements, there's blackouts, and there's some challenges starting to occur in 2010. So in 2015, we organized a project which meant a dam improvement project, because the previous project, there's still leaks occurring on the dam, it was losing water. There's issues with the pipeline that went through the dam. So we actually drained the reservoir, put this new facing wall on the upstream side of the dam, which sealed all the leaks, and we put a bigger pipe that goes through the dam, which was the cause of some of the constraints. So we made it a big diameter so you get lots of flow down the pipeline, and then we connected it in with the 2001 pipeline and took the water down to the powerhouse. Unfortunately, 2 years later, the pipeline failed further down the hill. So this is one of the concrete anchor blocks that was mixed with salty sand. It wasn't strong enough, and it split open in the pipeline. Came out of alignment, and there was a 50-meter water feature halfway up the hill. And so the local community had to get together, isolate the pipeline. You can see all the strops that were used to try and realign it. And this is halfway up the hillside, so the guys had to walk in, build some shuttering around it, and then get a helicopter in to re-pour the concrete. And credit to them, they got it up and running again fairly quickly. But during that period of time, we were running a diesel generator. And it was at this point that the community realized. They did a survey of the anchor blocks, and there was 18 anchor blocks that were all starting to fail and crack. And we realized we need to come up with a pipeline replacement project and do a better job of it this time, bury it, and get it sized properly for future energy growth. So over the period of 2019 to 2021, we took on a development project and we looked at several different routes to get a pipeline down the hillside. So the map on the left-hand side here, you can see multiple different routes that were considered. The dashed blue line was the original pipeline route, which is just a direct line from the dam to the powerhouse, but it goes over quite a steep cliff. And there's some hydrodynamic issues with that steep drop. What we also wanted to build in was an access track to make it easier in the future to maintain the dam and do repairs. So what we ended up with was a meandering access track, which is the grey line you can see, and then a pipeline roughly following that, but taking fewer turns to try and minimize the pressure losses along the pipeline. But it was quite challenging to pick out the route because it's quite steep, difficult terrain. There's also in a national scenic area, so we had to get special permissions and implement special ecological mitigation measures as part of the planning permission. So by 2021, we had a new access track in, a new pipeline laid, but it was very expensive and we needed support from the Scottish Government. So the community were very good engaging with local MPs. We had Kate Forbes and Ian Blackford, the local members of Parliament, to come support the community, understand what community constraints were and what they wanted to do to evolve and develop and get that initial grant funded support to get the infrastructure up to scratch. So by 2021, we had a new pipeline, but we didn't have a new turbine. So the top left-hand picture here is what the original turbine looked like from the 1970s, and it was reaching its end of life. So we had a new pipeline into the powerhouse, but we had to replace the turbine and runner, and we took that on with the local team and disconnected the generator, broke out the concrete plinths, and rebuilt it with a new runner and new generator, refurbished the main inlet valve. And the biggest improvement we obtained was with this new runner, which is the wheel, the metal wheel with the buckets on it that you can see. And by getting it redesigned, remachined, we got 30% extra power out of the system for every unit of water that hits it. So it's a huge improvement in terms of power output and energy efficiency. So by the end of 2023, we had the new hydro turbine in place, and we're getting a full power output of 320 kVA from the hydropower scheme. So we had the hydropower scheme fully secured and working well at that point. And the next stage was to improve the distribution system. So the previous overhead line had been refurbished in the 1980s, but the power poles were coming to an end of life. They were rotten, there was woodpecker damage, lightning damage, geese flying into lines and causing outages. So we decided to underground the network, which had its own challenges in terms of the terrain that we're trying to get over. And then we put in ground-mounted transformers. So we retired about 10 pole-mounted transformers and consolidated them into larger ground-mounted transformers. And at the same time, we looked at the old generator sheds. This is the main generator building that was built in the 1900s, and then diesel generators put in the 1950s when electricity first came to knoydart. But we took the diesel generators out, put 2 new diesel generators around the back, and we also put a battery storage system in this building. And this battery storage system does 2 things. It supports the diesel generators, so it means we don't need a big, larger diesel generator. So it supports from a peak power perspective and fuel efficiency perspective, but it also works with the hydro scheme. So we can put the hydropower scheme in water conservation mode, and we can reduce the amount of water that's passing through the turbine, and the battery picks up the grid control and the frequency control on the network. So it gives us a bit of water efficiency. So this is a new addition to the network that we're getting used to. And then the final project at the moment, which we're trying to wrap up, is wider monitoring and control of the networks. In the past, we didn't really have an overview of how the system was operating. So on the turbine, we've got this water conservation control mode. We've got an HMI or SCADA system for the hydro, more monitoring on the reservoir, and better understanding from the reservoir spilling and when it's getting to lower levels. And then a SCADA app and information that's available to the local customers and consumers to see how energy is being used on their microgrid and how their behavior, their consumption influences the wider energy system. So looking forward, it's certainly a case of build it and they will come. We've got a really secure energy system now. We've got lots of spare capacity. So for the next couple of years, we've got about 14 new houses that are going to be built out. And we've got new commercial industrial connections that are going in right now. We've got a new farm connection, a tree nursery, a brewery, a sawmill, and new B&Bs that are starting up to service the tourist industry. We're also looking at potentially extending the network around the peninsula and picking up smaller villages that are currently off-grid, and then also looking at decarbonising heating. So there's several houses there that rely on oil heating during the winter months. We want to switch them on to electric heating. But as that demand increases, we've got similar challenges that the mini-grids in Malawi have in terms of demand management, peaking power, and how do we use spare power when it's available during the course of the year. Sometimes the dam's filling and we want to use that water in some productive way. And then kind of ongoing considerations, which I think have also been mentioned from the previous projects in Malawi, is how do we make this a financially sustainable mini-grid? I think we're at a position now where the revenues at the right level that we can pay the annual operating costs for the network, and we can set aside a substantial amount of money each year for end-of-life asset replacement. So we know when the generator is going to fail, we've got a rough idea. We know what the maintenance regime on a dam looks like, the pipeline, and we want to make sure that we can provision the funds in the future for those large capital projects, and we don't have to rely on government grants in the future. And I think there's probably a question around optimal sizing of the microgrid to make that financially viable, and what size that needs to be from a customer base. And then kind of ongoing, improvements are standardizing the operating procedures, making sure we're doing things as safely as possible, responding to faults, improving our monitoring and optimization of the energy system. So that's all I've got for you today. And it's just a bit, I want to give a big thank you to Local Energy Scotland, who have supported this project in the past few years. And without their support and funding, we wouldn't have been able to achieve what we've achieved. And I'll hand back over to the chair for questions.
Okay, thank you, Kyle. Thank you. That was really excellent, and we can, I'm sure, all see some commonality between Scotland and Malawi. Are there any immediate questions for Kyle from any of those attending that people want to bring up just at this stage? No. I have a quick one on metering, really, because that was such an issue on a previous project that we heard about. Could you? How is the sub-metering done in the knoydart case?
Yeah, so we're just in the process of putting new meters in at the moment. So at the moment there's a variety of different old rotary meters that are in, mechanical meters, and some kind of newer, just basic digital meters. But we're putting in kind of smarter meters that allow us to do the time of use pricing that we've previously discussed. There's also an element of load control meters that we can remotely switch them on and off and do load limiting as well. So we can say to them, we want all customers to go to 5 kilowatts, and if not, we'll cut them off. So there's a bit of an educational piece with that, to making sure customers understand why we're doing it and the kind of data security around it as well. So we're definitely moving towards better smart metering and time use pricing.
Great, thank you. I mean, that sounds very impressive, I must say. So are there any other questions anybody wishes to raise with our speakers directly at all? From Damien, I think I can see your finger in the air, surprisingly.
Few more in the room as well.
Are we on?
Yeah.
Okay. Yeah, so all really interesting presentations. Thanks everybody for that, and interesting to see the development stages and how they kind of arose from community needs and ideas, and then figuring out how to turn it gradually into more professional and sustainable operations models. So interested in all cases, I guess. How have you figured out how to set your tariffs? And I know that there's different stages that everybody's at with this, and tariffs have been mentioned, and the need to look at tariffs again perhaps has been mentioned. But I'm just interested in how you got to tariffs in the first place. It's quite a difficult question. And then specifically for Cam, interesting to see that the maize mill came first. Quite a lot of mini-grids serve the populated, like they kind of connect up the households first, and then afterwards there's a big question about productive use of energy and business customers to make the business work. So interested in that the maize mill came first, and I just wondered if you were charging for that from the word go. Yeah, so for the maize mill, we were charging for kind of to use the maize mill as a competitive price. It's the same price that every other maize mill in our area was charging to mill their maize. It was just with the kind of resources available to us with our budget. Like when we looked into the distribution network, there's no way we could have afforded anything like that. When we looked at the wires and cables that were needed to hook up individual households, it was just completely out of our budget. So when we were thinking about how can we be most beneficial to most people, the quickest and cheapest way possible, maize mill was kind of a no-brainer. And just having a centralized point of charging. charging people's appliances and whatnot. So yeah, Maismo, and it was a good way to test our actual capacity of electricity from the get-go. But yeah, it was just the quickest way to help the most amount of people, you know. Before the Maismo one in Chile, typically women would have to hike their maize about 5 kilometers to Livingstonia, where the next closest Maismo was, or still is, but they don't have to do that anymore.
Good. Kyle or Jakub, any comments? Not Jakub, sorry, Samuel.
Actually, on the price side of things, so we actually, we did a piece of work last year to try and put in place a tariff setting policy for renewables. And so what we do every January is we review energy sales for the previous year, and we have a target revenue that we're trying to hit each year to cover annual operating costs and put a set aside amount of cash each year for end of life asset replacement. And we just make sure that we're trying to hit those revenue targets each year. So we adjust the pricing to try and meet those revenue targets. And at the moment we have 2 tariffs. One's just a standard tariff at 21 pence per unit, and one is a heat tariff, which is 11 pence per unit. So that's for direct electrical heating. So there's properties that have storage heaters or panel heaters, and so they get that lower heating tariff. But we're trying to get more people to move to heat pumps, and that'll still put them on the standard tariff, which is still favourable to oil heated pricing. But it's a political topic, and it's always quite difficult to agree on tariffs.
Yep. I'm not sure if Samuel's still online and whether he wants to contribute anything to that about the metering side of things, the tariff setting, sorry.
Yeah, so obviously coming up with tariffs has been an issue with us here in Malawi at Mega, because we can calculate the tariffs basing on our operation costs and everything. The problem is we are regulated by the national regulator, Malawi Energy Regulatory Authority. So for example, we did our work, we calculated, we saw that for us to operate sustainably, we need this tariff. We submitted it to the regulator. It took us 3 years without a response. And then when they were responding, they gave us, the tariff that wasn't reflective of, anything. So it has been a challenge, and it's still a challenge. But if you ask how we set up tariffs, we set up tariffs basing on how the local economy is, if they would manage, and our operation costs, and then we submit to the regulator, and then the regulator decides, because we are regulated. Thank you.
Great, thank you all. I believe there's maybe another couple of questions in the room, am I right? Maybe Benjamin and Aaron, is that right?
Yeah, so I'm Benjamin Carey, I'm a tourism consultant. I want to ask a question about community tourism. I was struck that 2 presentations mentioned tourism. I was in some cases before, sometimes after. I was recently involved in a German-funded hydro scheme in Zambia. It's 15 megawatts, this is so a bit bigger, but part of the scheme was looking at how it can contribute to the development of community tourism and just local fishing tourism. What I'm interested in is in Malawi, is there a sort of principle that there should be community tourism encouraged on the back of any new hydro scheme? And I suppose this is really directed at Samuel. But you need electricity for tourism, and tourism can make a big difference to the local community. So I'm interested whether this is part of the landscape or it's just luck when tourism develops beside hydro schemes.
Would any of the speakers like to pick up on any of that? No? Oh, you've baffled them, Benjamin.
I'm having a bad connectivity, but was the question connected to tourism and electricity?
Well, I was interested whether tourism is part of your landscape and objectives, or not. Does the government encourage community tourism to be developed when you are putting in new electricity schemes?
Yes, absolutely. For Mega, it is because, like I said before, Mega is owned by Mulanje Mountain Conservation Trust, which is most concerned with the conservation of Mulanje Mountain, which is largely improving tourism, and then looking at the communities that we are working with, they benefit a lot from, the tourism. There's a lot of huts at Mulanje Mountain, which if at all we can manage even to power them, that will just add up everything, and then it will make life very good. So to answer your question, yes, they are so much connected, and then the government is also willing to help improve the tourism industry. Even if we can energize the tourism industry, that's very much welcome. And this is what we are doing at Mega with the help from MMCT as well.
Thank you.
Okay. Kyle, do you want to say anything about that? I mean, knoydart obviously is in one sense looking for tourism, I think.
Yeah, I think yeah, if it wasn't for tourism, no one would be in knoydart. So it's tourism kind of sustains the economy there, and it's probably tourism that allowed us to access grant funding to upgrade the energy system to keep tourists coming. Yeah.
Excellent. Now, oh, sorry, Aaron, I think maybe has a question. Is that right?
Yeah, thanks everyone. Really interesting presentations. Two questions actually. So the first one links to the tariffs and setting the tariffs and the financial models. So I think everyone mentioned that grants were needed to get the project set up. And how far away are the projects from being financially sustainable in terms of having enough money in the bank to replace components and to grow? Is there, what needs to be done to make the project sustainable? Do they need to grow to a certain size to have more customers? Do you need to get more businesses or productive uses of energy? Or are hydro schemes always going to rely on grants? And if they do, that's fine. We just need to make sure that we can get the grants to keep them financially sustainable. And the second one was to do with climate change impacting rainfall. I know in Zambia, they rely on hydro for their national grid, and the main dam is down at 1% because of recent droughts. Is anyone experiencing erratic rainfalls and impacting the electricity output? And is there any way to mitigate against that, such as bringing in other sources of renewables? And is it quite a danger for hydro moving forward with climate risks? Thanks.
Great, thank you. Two good questions. There's a lot to unpack there, but any of the speakers like to start with one or both of those questions? No?
Yeah, I can start with sustainability.
Bravest, I think.
Yeah, for us Mega, it has been always the challenge. You see, in 2017, 2018, we thought that by then we had connected around 500 customers. And with the types that we were charging, we had been thinking that when we get to 1,000 connections, looking at the tariff and our financial model, we thought that would be sustainable. But then we go to 1,000 plus customers in 2021, and then we saw that we could not sustain even our operation. We still had some issues. And then we looked at our financial model and see that with the income from the income from the electricity sales, for us to get sustainable, we need to get to 3,000. Today, we are in 2024, 2025, we are at 2,150 connections, but yet we are not yet sustainable. We can sustain some of our operations, but we cannot connect any more customers. We don't, because we cannot manage to buy cables, we cannot manage to buy D-irons. So I wouldn't say that we are sustainable, but what we are looking for is we are trying to see what potential we have. If we could manage to make full potential of the resource that we have, Lichenya has got a potential to go up to 6 megawatts, but what we are doing is less than a megawatt. So, but when we look at the demand for the whole this is 2 megawatts. But you see, if we generate 6 megawatts, where are we going to do with, what are we going to do with the remaining 4 megawatts? So what we are thinking is, as the best way of getting this grid sustainable is to increase generation and then maybe sell the remainder to the national utility. This will help our, activities. But minus that, plan B is to increase densification, grid densification, because like I have said, there is still more customers, like 900. If we connect them using the energy that we have, we think we can get somewhere, because at the moment we are able to pay wages and salaries and pay for our, some of the operation costs. So I'm looking at these two issues. I think those two issues can help us much, because looking at our financial models and the number of connections, it has not helped us. Secondly, talking about the environment and droughts. Yes, we have experienced it at Mega, where in 2021, it was really bad. We were actually road shading. Actually, the Kenya River almost dried. We had problems. We had to make, some plans, in order for us to keep supplying electricity. So, yes, it can happen. But what else can we do? What we are trying to do is to make sure that we restore back the environment. And this is what we are doing on a serious note at the moment. And it needs investment as well. In addition to that, we have also seen that if we educate very well our communities who have now started understanding, we want them to understand the nexus between water, trees, and electricity, which is working, because we are telling them without water, you cannot have electricity, but without trees, you cannot have water. So it's working. So it's an area that needs also investment as well. So these areas, I think they will help us to sustain our activities. Let me stop there.
Okay, very good. I don't know if Cameron or Kyle want to mention anything briefly. That was just the questions, if you remember from Aaron, were about how close are you to having a sustainable system, and is there any effects of climate change that you're experiencing that you think that are worth highlighting? Don't feel like you have to, just if you wish to.
Yeah, so this is from a non-renewables perspective. The community boards are volunteer directors, and they recognise that they received a lot of funding from the government, and they want to make sure the energy company is financially sustainable. So that's a key part of our work at the moment. And so we've got our revenue target. We've done a lot of analysis to say at what stage in their lifetime the pipeline will fail, the generator will fail, and work out how much we need to set aside each year to make sure we've got a cash surplus. So we're trying to set aside about £50,000 a year for that over the next 20, 30, 40 years. And by 2027, it will be financially viable. So at the moment, we receive renewable obligation certificates, which is a government subsidy for renewable energy, and that comes to an end in 2027. That's a big hit to the revenue. So the next 2 years, we've kind of painted a plan to gradually increase tariff rates, try and sell more energy, so we can hit our revenue target without blocks in place, and still set aside the end-of-life asset replacement fund. So from this perspective, this type of the knoydart microgrid, it's got a good energy resource, it's got a growing community, so it will be financially viable, it will get there. From a climate change perspective, so we're noticing kind of two changes, or two influences. One is changing rainfall patterns. So rather than having rain spread out over a period of a month, it might all come in 3 days. And then it just overwhelms the dam. It goes over the dam and wastes that resource. So that's becomes a resource planning challenge. And then the other aspect is washouts. So if you've got huge amounts of water coming down the hill, washing out pipelines or parts of the dam, so having an impact on the infrastructure itself. So fortunately, we haven't had too big an impact, but we're starting to see the changes.
Good. Cameron, briefly.
Well, with like, for example, and also Samuel, if like, because obviously there's expenses that you don't know, like washouts, as you mentioned, and I'm sure Samuel at Mega, there's like, you can plan to a certain point, but you never, or there's always got to be an emergency fund. How are you finding it to set aside money to kind of to take on any unexpected emergencies?
Yeah, it's always you make a plan to say you think this asset investment fund is going to be there for the future to replace the end of life asset or the end of life, but I have a feeling there will be unexpecteds that will come up that we have to dip into that. So we still try to allocate a little bit each year for unexpected events. We are in a fortunate position that we do have insurance on the system, so we've got insurance in the hydro turbine, pipeline, and distribution system. It is quite a big expense each year. At the moment, we've said it makes sense to pay it, but it's a bit of a pool to say, well, do we want to self-insure in the long run and put that into an unplanned event fund rather than pay for insurance? So yeah, that's the approach we do.
Excellent, excellent. Thank you all. We've got a few people who wish to say a few things in the room, I know. So Joel, then maybe Laura from ProTerra, and then finally to finish with Jakub. And noting that I've done a very bad job of keeping us to time, but if Joel is there and he wants to say something about the BPP project, that would be helpful.
Okay.
If you like.
Yeah, as I was slightly unprepped, but like,
Just kind of highlight what's going on and
okay.
job opportunities for.
Yeah, sure, I'll take just like 1 minute then. Okay, sure, I'll try. So we're doing a project in Malawi, which needs a better name. It's called the BET project at the moment for various reasons, but and it's looking at kind of forceful product. It's looking at de-risking putting in mini-grids by if you can Aaron and Damien are involved in this, by the way, so they can but basically bringing in batteries, fairly large batteries, with kiosks, with a kind of charging kiosk, but for productive power, with the objective of collecting data and incentivizing energy use. So it brings it in as a low risk way to try and with some business support to try and productive use at the power hub. So at the power station, they're going to have welding and refrigeration and a couple of things like that. They're going to rent these larger battery packs out to do productive use applications in order to try and incentivize energy and allow people to explore what having access to energy will bring to their community, with the idea of actually bringing better quality energy than just the battery packs in the longer term. And these battery packs will integrate into a mini grid or could be then deployed elsewhere. They have got kind of demand response functionality kind of built in from day one. That's the idea. So they can become part of the demand response solution for the mini grid, or they can be deployed. But the idea is capturing as much data as possible on types of loads and building up load profiles and just beginning to understand on the power side and the business side. So it's going to come with some kind of business mentoring, training, support. Yeah, challenges are involved, but there's quite a lot of people in the room here who are involved in this. So yeah, that's kind of a flavour anyway. If that's,
Yeah, great.
Yeah.
And it's an Innovate UK funded energy catalyst project, so that's
it's a very modest and it's a very small Innovate UK project. We're quite kind of it's quite a small project, but we're hoping to but hopefully it will be set up by June, and then we're hoping to, if it kind of goes well, get a little try and get some other funding and to work with some other people to do a slightly bigger demonstration.
Okay, thank you. I mean, we might hear about that at future Scotland-Malawi partnership meetings, for example. It sounds very interesting, Joe. Laura, I think you were going to want to tell us of something, is that right?
So I think Laura was online from ProTerra Energy, and they had a hydro project in Malawi. It's a portable trailer innovation, and she's going to give us just a little.
You're right, she's moved on.
Is she still connected?
No.
No, well, we'll maybe get her back another time as well, so there's an
That's
interest.
fine. In that case, finally, I think in my list of people who wanted to maybe mention something was Jakub. Is that right? Jakub, are you there in the room or are you online?
Yeah, thanks, Stuart. I'm here in the room. Hi, everyone. I'm Jakub Vrba. I lead the Energy Access Research Portfolio at Energy Saving Trust. We primarily provide research and development grant funding to entrepreneurs and companies to drive technology innovation of off-grid solar appliances. So it's still energy access, slightly less related to hydropower. But I wanted to mention briefly 2 initiatives, one related to research and one to a networking event tonight. So on the research side, we are kicking off a new project next week with Solar Aid, which is a UK charity, and their social enterprise Sunny Money, which is based in Malawi. They work on a Light the Village program in Chipopoms district in Kasekula traditional authority in Malawi, which has no electricity grid whatsoever and very low affordability levels. So what they are doing at the moment is they are pre-electrifying households and schools with solar lanterns. Now, this is quite common already in off-grid areas of Sub-Saharan Africa, but mostly people have to pay upfront in cash or on pay-as-you-go basis. But these two models are just still not affordable for the areas that Solar Aid are working in. So they are trialing a new, basically utility model, like similar to what everyone discussed today on hydropower, where people pay very small fee and they don't have to own the system. And the Solar Aid and Sunny Money can replace batteries. If there is something that fails in the line, they can repair it and continue serving the communities. This is quite novel in the off-grid solar space. There are just 2 more companies doing this type of pilots in Sub-Saharan Africa, and we want to evaluate how feasible it is to scale this up as a pre-electrification for communities that are far away from grids and mini-grids are not feasible at the moment, with the idea that in the future, hopefully, the mini-grids would arrive and provide more kind of larger electricity for these communities. So if anyone is interested, please come to me to speak about that. And then on a second note, for everyone in the room, but also for people online, if you're based in Scotland, there's a networking event tonight here in Edinburgh, very informal. There's no agenda set or anything, but there are about 20 people who are working in energy access coming to the Queen's Arms at 6 p.m. Tonight. We have got quite a lot of people interested from program implementers side of things. We have got some investors coming, someone from the UK government also who's based in Scotland working on energy access. And we have also got some Chevening scholars from Africa who are studying here. I think there are 4 of them in different universities here in Scotland. At least 3 of them are coming tonight as well. So we haven't done this before. It's the first time, but seeing a lot of interest, we are thinking about doing this maybe twice a year or so to have some sort of a community here in Scotland who are working on energy access. So yeah, please come to me if you would like to also be added to this distribution list, because I might have missed some of you by accident. Thank you.
Okay, excellent. Thank you very much, Jakub. That's really helpful. So I would like to thank you all, personally thank you all, especially our speakers for taking the time today to prepare some materials and talk to us really about their really generally very exciting projects. And I'm sure, like me, you could see some commonality between what's happening in Malawi and what's happening on a Scottish mini-grid as well that Kyle told us about. So some really good work that resonates around that exciting area of hydro. So I'm going to hand over now to Stuart Brown for some closing remarks on behalf of the SMP. But thank you again for coming along.
Thanks very much, Stuart. A brief word of thanks to you, our chair, and to our speakers today, Samuel, Cam and Kyle, and to Joel and Jakub for their contributions as well. I think we've heard from and about really inspirational, ingenious people who are collaborating together in microgrids of people to give power to the people, and as we've heard, really enhancing the lives of families and communities in Malawi and in knoydart. Thanks also to Damien and to Aaron from the University of Strathclyde for all of their coordination efforts, and to my SMP colleagues, Chad, Dorothea and Nasim for all of their work. As Nasim said at the start, a video of this event will go online on the past event page of the Scotland Malawi Partnership website, together with the chat log and any of the slides that our speakers today are happy to go up there as well. We've got an interesting range of events coming up, all of which are listed in the upcoming events on the Scotland Malawi Partnership website, so I'd encourage you to have a look there. But in the interests of time for now, thanks very much to everybody for joining here in Edinburgh City Chambers and on the line from Malawi and elsewhere. We look forward to the next SMP Renewables Forum. Thanks very much.
Okay, thank you. Bye-bye, everybody.
Bye-bye. Bye-bye.
Bye. Bye, ciao.